Jai Bharat to all students. In last lecture, we start about with the linear equation. Okay, simple linear equation, and then difficult linear equation, which have three unknown and three equation, and how to solve these types of linear equation through matrix. And one of the method is Gauss elimination. Okay. In matrix there are also Gauss-Jordan method, but in this lecture we have talk about Gauss elimination, and in next lecture we will discuss about Gaussian-Jordan elimination method. Okay, so let's take about quick revision from last lecture. Okay, there are three stages we have talk about in how to solve linear equation through matrix. Okay, first stage is transfers this linear equation into matrix like AX into B format. Okay, coefficient of x1, x2 and x3, okay, and is equal to 4, 3 and 7 column matrix. Okay, we will transfer this linear equation into Ax is equal to B types of matrix formation. Okay, second, this is augmented matrix, which we will remove this column matrix for our own calculation. Okay, easy for our calculation, so that we will transfer this matrix into augmented matrix. This types of matrix is called augmented matrix. Then we apply some operation in matrix which called row operation, and we will transfer this matrix in triangulation form, upper triangle form, where in diagonal bottom of the diagonal there are always 0 value. Okay, this places is always 0, which is called upper triangle matrix. Okay, main diagonal, bottom of the main diagonal, its value is 0, which is called upper triangle. Okay, we will transfer this matrix in upper triangle. Then third stage is the back substitution. Okay, which we already know, back substitution. Okay, so this is the three stage. In a row operation we can apply 3 row operation. First, we can interchange row all. Okay, if this equation is a first equation, this is second, and this is third, so coefficient of first equation is in first row, coefficient of second equation in second row, coefficient of third equation in third row. If we name this equation number into another number 2, 3, and this equation is 1, then first equation 4, 5 minus 1 is in first row, 4, 5 minus 1. Second equation is 1, 3 and 5. Third equation is 2 minus 1 minus 3. Okay, and here also first is 7, second is 14 and 13. Okay, so in this matrix, if we changes one row to another row, its matrix value is not changed. x1, x2 and x3 is not changed. Okay, so we can apply this. We can also operate interchange between two rows. Okay, multiply or divided by a row to a non-zero constant factor. Okay, if we want to here we want to get value of 0, then this is the row 2. Row 2 minus 2 multiplied by R1. Whole first row we multiply with 2, then difference between these two we will get as a 0. R2 minus 2 R1. Okay, we will get as a 0. So we can multiply or divide it, okay, by a row, but it is always non-zero constant factor, okay, or add or subtract from one row to multiple of another row, okay, add or subtract. So these three types of row operation we apply in matrix to get upper triangle matrix, okay. Bottom of the diagonal value is always equal to 0, okay, it's called upper triangle matrix, okay. Now let's start with equation which have infinite number of solution. What is infinite? Here in last lecture or last example we have talked about a solution where we can get x1 is equal to something, x2 is equal to something, x3 is equal to something, okay, but here only we get one solution, okay, not infinite solution. But what if there are equations which have infinite number of solution, anything can possible, x1 is equal to anything can possible, x2 is equal to anything else, then how do we solve these types of linear equation through Gaussian elimination or matrix method, okay. So let's talk about some equation. This is three types of linear equation. First is we transfer this into augmented matrix, coefficient of 1 1 minus 3 2 minus 3 4 2 minus 3 4 1 minus 1 and 1 1 minus 1 1 minus 4 and minus 1, okay. So let's see, okay. So first of all what we do here, first is 1, then we did some row operation and get the value of this 0 to obtain upper triangle matrix, okay. So how do we get this value as a 0? If we multiply by with this row to 2 and subtract from row 2 R2 minus 2 R1, okay, so we will get 0 here. Why? R2 minus 2 R1. What is R2? 2. What is the value of R1? 1, okay, so we will get 0. Now let's talk about second row. Here R2 is minus 3 minus 2. What is the value of R1? 1, okay, here. So minus 3 minus 2 minus 5, okay, yes. Now third column, what is the R2? 4 minus 2. What is the R1? Minus 3 minus 3. Here minus minus plus is equal to 4 plus 3 to 6 is equal to 10, okay. Also here also we apply the operation, okay, not only this matrix, okay, is equal to only left hand side of is equal to also we apply these types of operation, okay. So not do not forget that minus 4 R2 is equal to minus 4 minus 2 into R1. What is the R1? 3 is equal to minus 4 minus 6, which we will get minus 10, okay, here minus 10. First rows remain same. Why? Because we did operation in only second row, not in first row, okay. So we will get second row. Now also for upper triangle matrix we want here 0. Okay, first of all આપણે first row second row get 0, then third row we want to apply 0, we want to get. So how we did that? Let's take 1, r3 minus r1 only. Here we don't know to multiply. Okay, why? Because 1 minus 1 0, so only operation is r3 minus 1. So let's done this operation. Here second minus 1 minus here 1, so we will get minus 2 here, minus 2. Then here 1 minus here minus 3, minus minus plus, so we will get as a 4. Okay, then here also minus 1 minus 1 minus here 3 into 1 3, so we will get is equal to minus 4. Okay, minus 4. Okay, so for upper triangle matrix now we have 2 0 here, but also we want to what is the upper triangle? Below of diagonal all the value are 0. Here you can see that he has a minus 2, so we also want to change that value. Okay, so how do we change? So minus 5 and minus 2, we want to change these steps these two values. Okay, how do we change minus 5? If here you can see that here second row is a multiplication of 5. So if we multiply with division with 5, then what will we get? Only second row. Okay, so we will get 1 1 minus 3 3, here 0 divided by 0, minus 5 divided by minus 1, here 5 10 divided 5 is equal to 2, and minus 10 divided 5 is equal to 2. Okay, sorry, minus 2. Okay, now here also it is a multiplication of 2, so we can divide it. Yes, 0 minus 1 2 minus 2. Okay, you also take if this operation is not possible, then you also can take another option like r2 minus 2 r1. So okay, meaning you can take any row operation you want, but we want upper triangle matrix. Here 3 value will become 0. Okay, okay, so this matrix we will get. Now here we want to get 0, so how do we get? If we multiply with this minus 1, okay, so r3 minus r1, so we will get 0. Yes, okay, why? r3 is minus 1, here minus, and r1 is also minus 1, minus minus 1 plus minus 1 plus 1 is equal to 0. Okay, so we did operation is the r3 minus r1, r3 minus r1. So how matrix we will get? So first row remains same, 1 1 minus 3 3. Here 0 minus second row will be same. We want operation in third row, so here 0 minus 0 0. Now minus 1 minus 1 0. Okay, here 2 minus 2 0. Here minus 2 minus 2 also, yes, minus 2 minus 2 also 0. Okay, now this matrix we will get. It is upper triangle. Yes, okay, we did some different thing than this example, but answer we will get as a same matrix. Okay, 0 0 0. Here they have multiply with -1, so -1 become 1, 2 become -2, and -2 become 2. It is a same matrix. Okay, so you can make any row operation you want as per your convenience, but last we want to make upper triangle matrix, whereas this 3 value is a 0. Okay, main objective is our make this matrix as a upper triangle matrix. Now here you can see that all the value third row are 0, so that means the variable x3, yes, x3 is the third row. Okay, x1 x2 and x3 is a third row, so you can apply x3 anything you want. Why? Because it's not depend, because this all the value are 0. Take any value you want, but this equation will not change its value. Okay, so let's take x3 is equal to t. T is the anything. Okay, x3 is equal to t, and applying back substitution we will get here. How do we get how do we apply back substitution? Here 1 x2 minus 2 x3, okay, is equal to 2. Second column is a multiplication of 2, third column is a multiplication of x3. Okay, so x3 is equal to 2, so x2 minus 2t is equal to 2. Here we get x2 is equal to 2 plus 2t. Okay, one value we will get x3 is equal to t, x2 is equal to 2 plus tt. Okay, only we apply the value back substitution. Okay, and if x3 is equal to t and x2 is equal to 2t, and we apply in this equation, so x1 is equal to 3 minus x2 plus 3x3 is equal to what we'll get after calculation, 1 plus t. Okay, so if you take t is equal to 2, t is equal to 2, then we will get x3 is equal to 2, x2 is equal to 2 plus tt means 4 plus 6, and x1 is equal to 1 plus t means 3. Okay, this this is the solution of this equation. If we get t is equal to 1, then x3 is equal to 1, x2 is equal to 4, and x1 is equal to 2 also. Okay, so this is the also solution of this linear equation. So you want you get my point that if you take is equal to anything from R, you will get different types of solution. So this equation has a infinite number of solutions. Okay, because you can take t is equal to anything you want, and after that you get the value of x1, x2 and x3. So this linear equation has a infinite number of solution. Okay, so if in any row after row operation or upper triangle you get the value of all the row as a is equal to 0, then you can apply say that this linear equation has a infinite number of solution. Infinite number of solution. Okay, now let's talk about next example types is rocket and velocity. Okay, the upward velocity of a rocket measured at 3 different times is shown in the following table. Okay, time is 5, 8 and 12, which means at the 5-second velocity is this, at 8-second velocity is this, and at 12-second velocity is this meter per second. Three different types we measure the velocity. Okay, this is the table. Okay, velocity here you can velocity over time is 5 to 12. You can see that here we only measure three different times: 5 at the 5 second, at 8 second and at 12 second. Okay, is approximate by quadratic expression as a velocity is equal to a1 t square plus a2 t plus a3. Here t is the time, here t is the time, v is the velocity. Okay, so find the value of a1, a2 and a3. Okay, this is the equation. Okay, so if in exam these types of example appear, then how do you know this is an example of Gaussian Jordan or Gaussian elimination or matrix? Okay, so first of all we make linear equation with this. Here you can see that this is the linear equation. Velocity is equal to a1 t square plus a2 t plus a3. Okay, but in last example we have linear equation as x2, x3 and x3, but here this example it is the value of a1, a2 and a3. So okay, so this is a linear example. Okay, three types of linear example. So if you get idea of linear equation, then you can solve this is as a Gaussian elimination. Okay, as a matrix method. Okay, so now let's make here it is the only one linear equation, but we want three or more equations so that we make matrix. Okay, so how do we get here? First, at 5 second velocity is 106.8. okay, so velocity 106.8 here, first equation 106.8 at the time interval is 5, so we can value put at t is equal to 5. Okay, so 5 square is equal to 25 a1, here t is equal to 5 a2 plus a3. Okay, first equation made. Now let's talk about at the time interval 8 second and velocity is 177.2 meter per second. So here 177.2 is equal to t square means 8 square. Okay, 16 for a plus a to t means 8 a to 2, 8 a2 and plus a3. Now let's talk about third time interval. At time 12 second velocity is 279.2. so let's again take this equation and make third equation. 279.2 is equal to t square means 12 square. 12 square is 144 plus 12a2 plus a3. So we get three different types of linear equation. So now it's simple, you can solve this three linear equation into matrix form, then apply row operation and transfer this into upper triangle matrix, and then after upper triangle matrix made, then with the method of back substitution you can get the value of a1, a2 and a3. Okay, so first we transfer this matrix form into matrix form, augmented matrix. Here is the coefficient of a1 25, coefficient of a2 5, coefficient of a3 1, coefficient of here second row, coefficient of a1 is 64, coefficient of a2 is 8, coefficient of a3 is equal to 1, and third row, third equation, coefficient of a1 is equal to 144, coefficient of a2 is equal to 12, and coefficient of a3 is equal to 1, and column matrix a1, a2, a3, and here is equal to velocity value 106.8, 177.2, 279.2. Okay. After solving these types of matrix into triangle, and we will get a answer of A1, A2 and A3. Okay. So if in example there are not included any linear equation or matrix, but after this equation, this type of equation also can be solved by transfer into matrix and then Gaussian elimination method. Okay. Okay. Now in last lecture I will give these two as a assignment question. Now you have to solve these two types, third and fourth question with the help of Gauss elimination, and you have to solve this linear equation. Okay, and upload it in RNWIET application. Okay. Okay, and now in next lecture we talk about Gaussian elimination, but with the help of partial pivoting. Okay, some new topic is there, but topic is our remain same, Gauss elimination method. Okay. So you have to solve third and fourth as your assignment question and upload it in RNWIET application. Okay. So your lecture is now completed.